Look, there are three main characteristics that a smart grid should have. Firstly, it should be instrumented with reliable telemetry devices that provide accurate and real-time information about the performance of the grid. Secondly, it should be integrated with the key systems that manage the network, such as control room systems, outage management systems, and asset management systems. But most importantly, it must have systems that allow intelligent decisions to be made once the information from these key systems is brought together. Each utility is going to find different benefits from implementing a smart grid, but the ones that are most commonly seen are an improved ability to deal with peak demand and also to direct both their network capital and also their demand response activities to focus on the right areas, being informed better about the way that the network actually operates, so that they can deploy their capital more efficiently by identifying areas of the grid that have got poor power factor, poor power quality or incorrect voltage, and facilitating those remedial actions. They also assist utilities in achieving increasingly better reliability targets that governments are now demanding of utilities. They can put monitoring devices into the grid at strategic locations and assist operators in identifying the location of faults and also using remote control capabilities to more quickly fix the faults when they do happen. And in the future, it's quite possible that the use of these technologies will allow them to predict a fault before it can happen and possibly work around it. They can monitor and control some of the new intermittent two-way power flows that are going to result from renewable energies such as wind and solar, and there will also be productivity benefits that are associated with not having to visit equipment in the field to take measurements, but being able to get access to those measurements remotely. That's not an exhaustive list by any means, but they're indicative of the sort of benefits that you can receive from implementing a smart grid. Well, there are many different areas of benefit that can result from putting in a smart grid, and each utility is likely to see different ones. But at a high level, they come down to a few different categories of being able to more efficiently manage the network, being able to deploy capital more effectively, being able to more productively run the network, and also more rapidly identifying faults when they arise. They're the high-level areas, lots more in detail when you look at a specific utility's needs. The PowerSense device can be the eyes, ears and hands of a smart grid. Its optical sensing technology allows it to be installed onto the live medium voltage and low voltage cables and monitor the state of the distribution network. Once that's installed, it can then report the measurements from the grid as well as alarm indications from other monitoring equipment in the network. And it's got remote control capabilities that allow the device to open and close switches remotely in the field as requested by the control room that runs the network. IBM is then able to integrate the information from the smart grid device with the utility's key systems to provide the information to many user groups within the organisation to support a number of different functions such as fault management, network operations and network planning. IBM has offerings across the full life cycle of smart grid implementation. We're able to help utilities understand the business benefits that would follow from implementing a smart grid, and also some of the organisational changes and process changes that they need to make as well. We're able to design and build the mission-critical IT systems that they need to run such a smart grid, something that can be the backbone and the brains of the smart grid. We're also able to supply industry-leading hardware and software to help you analyse and make sense of the huge amount of data that comes out of a smart grid. And our research labs are even now working on more innovative and new ways to do that as well. We've got a great research lab working on that. And last but not least, we work with a number of industry bodies such as Gridwise and the IEC Standards Committee in looking at ways to standardise the smart grid. Look, it's a hard question to answer what the smart grid will look like in 20 years' time, because many of the technologies that will be available then have not even been invented now. But the major change is going to be that the generation and storage functions will be distributed throughout the grid using renewable technologies such as solar and wind, and also storage technologies such as battery banks. And we'll move away from today's centralised one-way flow of energy from generation to customer to a more of a mesh of multi-directional flows. And that's going to need a high level of intelligence to manage, optimise and safely operate the network. There's going to be increasing use of electric vehicles, and that'll require new solutions for managing the additional load that those vehicles will put on the grid. There'll be systems that manage the grid will need to have much more sophisticated fault prediction and analysis capabilities, as well as self-healing logic. And the monitoring of the entire grid is going to be a whole lot more comprehensive to improve asset management processes, fault management processes and security as well. And inside our homes, we're going to have devices that allow us to manage our usage more efficiently and be much better informed about the way that we use our energy. And lastly, most of the switching of the distribution network will move away from the manual processes that we've got today to fully automated. There'll be increasing use of video to monitor what's happening in the grid. Staff will have tools that will make them more productive, like speech recognition for data entry, field computing devices that allow them to do all their work without having to come back to an office. No doubt there will be many other new innovations as well, but one of the key things though that will underpin all of this is having flexible computing devices such as the PowerSense device deployed throughout the network to meet these emerging new requirements.